Hello everyone, today is day 49 of solving a LeetCode problem every day, and today I'm going to be solving Debounce. So this is going to be another JavaScript question. So given a function fn and a time in milliseconds t, return a debounce version of that function. So all a debounce function is a function whose execution is delayed by t milliseconds and whose execution is canceled if it is called again within that window of time. So basically what it's saying is, let's say we have our delay is 50 milliseconds and the function was called at 30, 60, and 100 milliseconds. These first two function calls are going to be ignored, since basically what happens is we call the function at 30 milliseconds. We have this delay of 50 milliseconds. So we check, has this function been called again within this time frame? And it has. It's been called again within 30 milliseconds. So this function call gets ignored and we get to the second one. And now again, we see if this function has been called again within 50 milliseconds, and it has in 40 milliseconds. So this gets ignored, and finally this gets called. And here it pretty much says if instead t is equal to 35 milliseconds, this first function call would be canceled since this gets called within 30 milliseconds. But then after this, this function call is going to get executed at 95 milliseconds, and this third function call gets executed at 135 milliseconds. So both these don't get canceled since nothing gets called within the time frame right here. So I guess another way to explain what debouncing is, or how it may be used, is, let's say we have this e-commerce site, AliExpress, and let's say I might go to search like water bottle, right? Every time we add a letter into the search bar, we're going to be making a separate API call to, whatever database we might be querying for, these search results right here, or these recommendations, just depending on what is being used. But the whole idea is while a user is still typing, we don't need to still be making the API calls. So what I mean by that is we don't really need to actually make this API call until the user is done typing out his query. So what we can do is implement debouncing. So like as we are typing, we might implement some type of like 50 millisecond delay for the API call to happen. So as we are typing, for example, water, we don't get these search results until we finish typing out the whole word water. So essentially what that can do is just optimize our API calls. It can be expensive to make a bunch of API calls at once, so it might be a lot more efficient to do it that way. So the way I'm going to solve this is by using a closure. So first we're going to start out by declaring a timeout variable, and this inner function that gets returned is going to have a closure over this variable. So we're going to have access to this variable at all times. So next what I'm going to do is I'm going to create a timeout, and this timeout is just going to call the function alongside the arguments. And what I'm actually going to do here is I'm actually going to apply, and let's go see the documentation. So if I go to Mozilla and type in apply, so here it says that the method of the function instance calls this function with a given this value and arguments provided as an array. So the apply method takes in an array and this keyword. So we're going to pass in this, and since args is already being converted into an array, we can just pass in args itself. And then so that's our set timeout, and then we also want to pass it the delay, which is t. So the reason why I'm using apply over here is because this function right here can either be an arrow function or just a regular function. And I'm not going to go into too much details about how this works, but with arrow functions, they don't actually have a this keyword, so they inherit it from whatever its lexical context is. So what I'm basically doing here is ensuring that the this keyword is consistent, whether the function is an arrow function or a regular function, right? Because if it's a regular function, the this keyword just depends on wherever this actual function is going to be called from. So we don't really have to worry about regular functions as much. But for arrow functions, they're just not going to have a this keyword. So we just want to make sure that we give it the proper this keyword. And the other thing I'm going to do is I'm going to clear the timeout here. So basically what's going to happen is every time this inner function is called, it's going to clear the timeout, then create the, or I forgot to do this too, but we got to set the timeout to be this timeout right here. But pretty much what happens is we clear it and then we rerun it. And the whole idea is if this finishes before this is called, then this will be executed. And yeah, I mean, it's pretty much that simple. So if I run this, it's taking a minute, but it accepted. And if I submit it, got accepted too. So again, I'm not going to really worry about time complexity and space complexity here, just because, you know, that it's just, it more just depends on whatever this function here is. But I guess one thing I do want to note is, since we are debouncing the function and we're adding a delay, whatever function gets passed in here, it's just, you might want to note that it's going to take a little extra delay to run. But yeah, that's my solution for the day.